the second keynote of the ISARC 2020. In Japan, it's 2 o'clock p.m. It's a quite fine day today with a perfect blue sky. Good afternoon from Japan. My name is Tateyama, chair of the local organizing committee. It's a pleasure for me to introduce a speaker of today's second keynote lecture. The international race and collaboration for developing the lunar surface is becoming to have a reality in the world today. So it's not just a fantastic story now. In Japan, the Japan Aerospace Exploration Agency, we call JAXA, is studying a plan to build a base on the moon. Of course, the special technologies are required to build a base on the lunar surface due to an environment different from that on the Earth, such as low gravity, no air, and limited instrument or so on. So JAXA is developing technology to build a lunar base on the lunar surface in cooperation with some companies. In the research, the construction robot is expected to play very important roles because it's difficult for a human to be directly involved in work on the moon. If some unique technologies are successfully developed for building a lunar base, even under such tough conditions, and if we can implant them to the construction on the Earth, it will be an unique construction robot that has never been seen before on the Earth. Therefore, we are much interested in the research and the development of the project of the JAXA. Today, I would like to invite Mr. Naoki Sato of JAXA to the keynote lecture number 2. He will introduce the international space exploration and the Japanese lunar activities. So, Mr. Sato, please start your lecture.
Thank you very much, Tateyama-san. I'm very pleased to show our plan for the lunar exploration, and let me jump into my presentation. Okay, again, my presentation title is International Space Exploration and Japanese Lunar Activities. And first of all, I'd like to talk about the latest status of International Space Exploration Program formulation. And the second is JAXA's scenario for the lunar surface mission. And finally, I'd like to explain about the concept of the lunar base construction. Okay, this chart shows the history of the international space exploration. It starts with the President Bush announcement of the new space exploration plan in 2004. And after that, the International Space Exploration Coordination Group to establish the global exploration roadmap or scenario for the use for the international partners. But in 2010, Obama president terminated the constellation program and reoriented the goal of the human asteroid mission. However, after the Trump was inaugurated, he directed to going back to the moon, and U.S. published Artemis plan. And right after that, just 2 months ago, ISARC published the latest global exploration roadmap, which is a supplement for the lunar exploration. I'll explain about this exploration roadmap a little bit. So this is published. This was published on August 28th. And we are expecting this roadmap will be used for the dialogue with stakeholders, including politicians, and also the international commercial partners to promote the cooperation. I'm sorry, this chat a little bit busy, but shows the very important objectives of the lunar surface exploration. Many of them is to demonstrate some several key technologies such as a human landing and ascent capability and cargo delivery capabilities, EVA capabilities. EVA stands for the extravehicular activities, and human long-range traversing and long duration habitation, and also the resource utilization and so on. This is the common objectives among the international partners, and we are targeting to promote these objectives. And for the to develop the scenario, we took the step-by-step approach like this to achieve the 12 objectives. The first phase is boots on the moon. And phase one, phase two is a lunar exploration, expanding and building. This phase two is divided in two phases. 2A, focusing on the human landing, ascent, and cargo lander and long-range traversing capability demonstration. And phase 2B is focusing on the demonstration of the long habitation capability and crew health and performance capability, and ISRU. ISRU stands for the in-situ resource utilization. And phase 3 is a kind of sustained lunar opportunity by the government mainly, industry mainly, and the government will start the and shift the investment to the human Mars mission. This chart shows the overall exploration mission scenario. Phase one is the preparation and achievement of the first human landing mission in the 21st century. And after that, the human lunar mission will be performed annually. And in the lunar surface bar, you can see many of the small circle, which is for the robotic missions to demonstrate technology and also to investigate the resource or environment of the moon. And this just shows a more detailed mission scenario, mainly for the phase 2 from 2025 to around 2035 timeframe. And as you can see here, we are bringing several assets to the lunar surface to explore the lunar surface globally, such as the small pressurized rover and power element and habitation modules, and also the ISRU pilot plant during this phase. And the place of the exploration area is basically South Pole region, as you can see in the blue bar. In the first period, but after the several missions, as you can see in the red or green tab, we are going to the off the pole, such as Schrödinger Basin or Antoniadi or South Pole Aitken Basin. But after that, we are going back to the South Pole to conduct more longer duration habitation missions with more strong power or habitation capability. This chart shows the end state of phase 2. We need many of the elements to be used for the global lunar exploration. and such as the ISARC plant and power plant and habitation modules, as well as the transportation capabilities, such as the lander or crew vehicle or rovers. And this chart shows a future vision of a fully developed lunar economy. And we are expecting many of the industry or private company will utilize this human base for the sustainable lunar exploration and missions. And that was for the international human lunar exploration missions. And maybe you know the US Artemis program. This is one of the international space exploration, but it's a core of the international space exploration program. This will be enabling the human mission to the lunar surface beginning in 2024 and extend the human lunar missions to prepare for Mars. And the first element of the human lunar exploration is a gateway. Gateway is put on the lunar orbit, as you can see here. The gateway is very simple station, consisting of the power and propulsion module and the small habitation module and the logistics module. And the crew vehicle launched by us, the big rocket from the Earth will be docking to the end of the habitation module. So the first lunar mission will not be utilizing the gateway, but after the first mission, the gateway will be utilized as a transition point from the Earth to the lunar surface. From now, I'd like to talk about the JAXA scenario for the lunar surface mission. We have basic plan on the space policy. It's revised in June this year. And this basic policy for the decade anticipation for the next 20 years. And the summary of this for this international space exploration from the basic plan is to participate in the Artemis program and also the landing on the moon's polar area. This is a robotic mission, not a human mission. And also the establish the essential infrastructure system for the lunar activities, such as lunar rover or other utilization plan. Also, we concluded with NASA about the bilateral agreement, which is called JEDI, and we committed, Japan committed to contribute to the Artemis program by providing some components to the gateway habitation module and logistics resupply and lunar surface data from the 3 mission or LUPEX mission, which is the water prospecting mission. And also the we are going to study with NASA about the crewed pressurized rover. And NASA will be committed to the Japanese astronauts flight opportunity for the gateway and lunar surface exploration activities. Those two charts summarize about the political status for the lunar exploration. And this is our JAXA space exploration scenario. So for the moon, first new mission was Kaguya, which was orbiting the moon, And the next one is a SLIM mission, which is a smart lander for investigation moon to demonstrate a pinpoint landing mission in the Japanese fiscal year 2021. And then the next step is the lunar polar exploration to find out the water distribution around the lunar south pole. The launch date will be around 2023 timeframe. And the next mission will be a lunar landing demonstration mission around 2026 timeframe. After that, we are expecting about the full-fledged lunar exploration. From now, I'd like to talk about the little bit detail about each mission. So the lunar exploration mission, which is the lunar LUPEX, this is to confirm the amount of the water present in the lunar polar region and its availability as a resource. This mission consists of the two main systems, such as rover and lander. And lander will be, this mission is a collaboration between India, and India will be developing the lander, and JAXA will be developing the rover. And we are also studying about the mid-class lander, which is a versatile lander, could be used for the cargo transportation to the lunar surface, and also could be used for the science mission, and could be evolved to the reusable human lunar lander. Currently, the payload mass target is 1 ton, and landing accuracy will be within 100 meters. And our target is to have a global access of the moon. And for the preparation for the full-fledged human exploration, we are very heavily investigating about the crewed pressurized rover with Toyota to contribute the long-range excursion capability for the human lunar surface exploration mission. The number of crew will be 2, but 4 for the contingency, and travel distance is 10,000 kilometers and max speed 20 kilometers. And the launch date, target launch date will be 2028. Also, we are studying about the ISRU plant. Again, the ISRU stands for the In-situ Resource Utilization, mainly for the water, but could be regolith itself. And this ISRU plant produces liquid oxygen and liquid hydrogen from the water in the regolith. And this liquid hydrogen and liquid oxygen will be used as a propellant for the rocket, and it's a reusable human ascender, or could be used for the export hopper on the lunar surface. But the plant size depends on the content rate of the water, and so that the content rate water is very important. That's why our LUPEX mission investigate how much water will be in the regolith. So the performance of the ISRU, we are targeting to produce water from the regolith about 75 tons per year, and mass will be from 10 tons to several tens tons, depending on the content rate of the water in the regolith. And we need the power of the several hundred kilowatts. And to get such a big power, the location should be the south pole of the moon. Then the last part of my presentation will be the explanation about the concept study of the construction of the lunar base at the JAXA with the support of the industries. The target of human lunar base is like this, consisting of the actually 4 to 5 zones. The area is 3 to 4 kilometers. The assumption for this conceptual study, this is from about the middle of 2030s, I would say, for about 5 years. And we are assuming the annual short stay missions, and but also the once or twice a year, the construction equipment will be sent from the Earth using the unmanned mission, and the work will be done by mainly remotely from the ground, and yes, and another assumptions, we are applying the ground-based construction techniques to the actual terrain on the moon, and basically unmanned constructions is assumed, and but for the because this is a very initial concept study, we are removing some constraints of the environment, such as vacuum and low gravity and the soil differences from the Earth soil, and but the factors that affect the construction method and process is incorporated, such as the amount of the transport and the number of transport and the period of the operation. And this is the kind of result from the conceptual study. The first one is the layout plan of the lunar base, considering the elevation and the soil texture and the topography and sunshine rate and logistics. These were very closely examined for placing the zones. And the many industries studied separately, but finally they chose the almost the same location around the South Pole. And for the landing zone, 4 different construction methods were studied for the comparison, such as asphalt paving and concrete pavement and soil improvement method, and laying secondary product concrete panels. After that, after the comparison, the stable processing method based on the soil improvement method was selected. For the construction machines, requirement for these elements were arranged and considering the lunar environment. And we developed some concrete machine concept, but the detail will be the next step. For the application structures, we have considered several consideration items such as safety in emergency and habitability and how to use the public area and scalability and so on. And also the specificity of the area and the number of modules and were also studied. So we have evaluated whether this scenario and construction of the base based on the conceptual study, and in the first 5 years of 2030s, As shown in the next chart, the results of the study showed that the scenario can be achieved. The construction method shown in the schematic plan. So this is Japanese. Sorry, in Japanese, and also it's very busy. But it's the example of the process chart of realizing the base. So based on this chart, we thought that the construction of the lunar base within the 5 years in 2030 timeframe is feasible. And this chart shows the participation company and organization for the conceptual studies. I won't go the every company name. So the beginning of 2020, first first of all, the gateway is constructed around the moon and expanded step by step. After several initial missions and preparatory missions, lunar base construction will start with the construction of the landing zone. The next step is to construct the power zone to produce the power for the base and the further construction. At the resource utilization zone, the fuel will be produced from the water in the regolith, and also the construction of the materials will be made by the regolith. And this is the habitation module, and for a long duration stay, module will be covered by a regolith for the protecting from the severe radiation. For construction of the base and the plant, many of construction machines are needed to promote the technology development of the construction machine. JAXA is conducting the collaborative research with Japanese industry for safety and cost-effective. Such construction will be mainly done by remote operation and automated operation. We are also planning to start research on space food production. Now the base is completed. Based on this base, global exploration on the moon will be enabled. Using the Spoce rover, which may be provided by Japan, enabled a long distance exploration of 100 kilometers. At the fuel plant, fuel is produced for later to get back to the gateway station and also used for global exploration. After the mission, every mission completed, astronauts are going back to the gateway and going back to the Earth finally. That's all for my presentation. Thank you for the patience.
Thank you so much, Mr. Sato. So I want to have some question and answer time. So if you have any question or comment to Mr. Sato, please ask them on the chat board. So I will select some of them and ask to Mr. Sato. So now, Mr. Sato, do you see the chat board?
Just a moment, please.
Yes.
Chat board.
We have the 3 questions now.
Sorry, I can hear. I can see the question on the chat board.
Okay, so I will read the questions. Okay.
Thank you.
So first question is, what constellation is there the reference points to locate the benchmark positions? any rule like the public reference point? That is his question. So I think how do you determine specify the reference point in the construction of the lunar surface?
Okay. Basically we are thinking to put the lunar base on the lunar south pole, and in detail on the top of the rim of the crater, which can get the very good sunshine rate, and also the at the top of the rim, a relatively flat area. So that's why we think the top of the rim of the crater in the South Pole area will be the good reference point of the lunar base construction.
So do you have the exact map of the lunar surface already?
Yes, of course. The Kaguya mission of the JAXA has already flown around the lunar orbit and made very detailed terrain map of the lunar surface, and also the other missions from international partners such as NASA or India or Russian made also the same terrain map. So we have many of the data of the terrain map.
Okay, thank you. So second question. Second question is the construction duration is highly affected by the behavior of the materials in the specific environment. How do you accommodate these uncertainties in construction project planning? So he is asking about how to treat the uncertainties in the planning.
Okay, it's a very good question. So in the space, we have always uncertainties, and for the lunar surface, there are many uncertainties. So that's why before the actual construction starts, I think we need many of the precursor missions by human and also the robotic missions. So firstly, in early 2020s, many countries planning to send robotic precursor missions to the South Pole to investigating the water distribution. This is one of the eliminating such uncertainties. And also the other robotic missions will investigate lunar environment and also the condition of the lunar soils. So using those kind of robotic precursor missions, we are going to eliminate such uncertainties. That's our plan.
Okay, thank you. So Mr. Sato, please on your camera. I want to see your face.
Sorry. Yes.
Okay. Okay. So there are many questions that I cannot.
Okay.
So ask all the questions. So I'll select some of them. So okay, this is the simple question. For the road construction using asphalt or concrete or so on, you said, I think so. So what is the plan of getting these raw materials? How do you get such kind of the material, asphalt or concrete or so on the lunar surface?
Yeah, I'm not the expert of the such a study, but I think that basically we try to use the regolith as one of the materials to create such a concrete or for the road or landing site. So, but I think it's not maybe not enough. So we need some materials to develop such a asphalt or concrete from the earth.
So you said that you can get the water from the lunar surface, so the water can be used for making the concrete or asphalt or so on.
Yes, that's right.
Okay, thank you so much. So next question is, how do you deal with lunar dust avoiding to penetrate mechanism and the facilities? I think how to deal with the lunar dust. It's a very fine dust.
Right. It's a very critical problem, especially for the spacesuits. So we are not only JAXA, but many countries are investigating how to protect such a rigorous contamination from the spacesuits, and also to remove that rigorous from the airlock by some mechanical method and also some electrical method. So, but still we are now investigating the technology to protect the contamination of the rigorous right now.
Okay, thank you. So one more question. It's a very long question. So I wonder if it also involved the humanoid robots or robot arms to be used for construction activities on the moon. Is it possible to use such kind of the robot? Is it practical?
Oh, of course, many intelligent robotics should be used for the lunar exploration. So we believe that the human and such a robotic collaborative mission is very important. So there is some safety risk. We should use such a robotics first. Then after the confirmation of the very little risk, then the human can go to that place. So such a collaborative operation or mission between human and robotic is necessary, we believe.
Okay, thank you so much. So there are many questions, but now we have come to the end of our allocated time. So I would like to close the keynote number 2. I expect that a lot of construction robots will practically play an active role in the construction of the lunar base in very near future, I think. Mr. Sato, your lecture shows us a new field of construction robots. So thank you again for your hopeful topics. Thank you so much. And thank you for all the audience. I would like to close the keynote now. Thank you.
Thank you. Bye.